Welcome back, guys. So this is problem 52 and here we are asked that a number is selected at random in the interval -1 to 1. Okay, so we have two events here, event B and event C. Why are they not called event A or B? Because the same question we have solved previously and the link of that question I will put in the description. Okay, so here we have two events where the event 1 is the modulus of x minus 1 by 2 is less than 1, while the event C has x greater than 3 by 4. So we have to find the probability of B given C and probability of C given B. Okay, so let me now again see that what was there. So there we had these lines, okay, and here we had this 1, this -1, okay, this is minus 0.5, this is 0.5 as well, and here we had basically two events. So event B, basically there was, okay, so event B, there was, I basically represented event B with this green color. It basically started from here and went from there to here. Okay, so this was what, this was the event B. Okay, similarly for event C, we had used the blue color and it started from this point, where this point is 0.75 or 0.75 is also 3 by 4. It started from here, okay, and ended here. So here it was this event. So this was the event C. So we have also seen that the probability of B was how much? The probability of B was 1.5 divided by 2. So that was 1.5 divided by 2 was how much? It was 0.75. Okay, and the probability of C was 1 minus 0.75 divided by 2. So this was what? 0.25 divided by 2. So it was 0.125. Okay, how did we calculate it? What does it mean by this 2? So 2 was what? 2 was basically this overall distance, okay, between this -1 and +1. This was 2. Okay, similarly here in B, the distance between these 2 points was how much? This was 1.25. So the probability of B was calculated by dividing this 1.5 by this 2, okay, as I have done here. Similarly here, this was the event C and the distance here was 0.25. okay, so again we have used it and divide it over this 2 as well. I have also explained it in my previous lecture and the link of that lecture is already available in the description box, so you can look at those explanations as well. Okay, so now what we have to do, we have to find the probability of B given C and probability of C given B. So what is here, we can see that in order to find the probability of B given C is always equal to the probability of B intersection C divided by the probability of C by the conditional probability. Okay, but we don't know the value of probability of B intersection C. So the value of probability of B intersection is how much? Let me go towards here as well, and here we can see that the intersection between B and C is again this point. Okay, so that is the intersection where the both has been occurred. So therefore the value it has is 0.25. okay, so in order to find the probability of B intersection C, what we have to do, we have to divide it over the overall distance, which is 2 here. So again I will get here 0.125, which will remain same here. Okay, so now in order to find the probability of B given C, the probability of B intersection is given, C is given, so that is 0.125 while the probability of C is how much, that is already calculated, and that is also 0.125. So, writing 0.125, what I will get? I will get here 1. Okay. So, it says that if C has occurred, there is a 100% chance that B has already occurred, because we can very easily see here that here this event is also a part of my event C. So, whenever it occurs, it also occurs, because that is the subset of my event B. Okay. So, therefore, it basically satisfies what we can visually see here. Okay. Similarly, in order to find the probability of C given B, what we have to see again, probability of B intersection C, and dividing it over the event which has already occurred. So, that is B. Okay. We have already found out the value of probability of intersection C, and that is 0.125. Okay, and dividing it over probability of B. So, let me see that what is probability of B, and that was 0.75. So, that is 0.75. So, let me calculate it. So, calculating it, 0.125 divided by 0.75. Okay. So, that is 1 over 6 or 0.167. So, 0.167. So, that is the probability of C given B. So, that is, there is a 16% chance that if B has occurred, that C will also occur in it. Okay. So, that is it for today. We have discussed another application of the conditional probability by using this line function, and this is basically a part of our previously done question, which was basically the question number 17 or so. So, we have also discussed it here. So, I hope you have understood it, and I will see you with some more interesting questions in our upcoming video. Thank you so much, and I will see you soon.